Alright guys, welcome to today's tutorial, and today we are going to be looking at mean value theorem. Mean value theorem states that if a function f of x is continuous on a closed interval x1 x2, differentiable on a closed interval x1 x2, then there exists at least one number x0 in x1 x2 such that f of x2 minus f of x1 is equals to f prime of x0 into x2 minus x1. So what does this imply? If we are given a curve, if you have to determine the curve whether it satisfies a mean value theorem, so let's say we are given that f of x is equals to s cubed minus 8x minus 5, and we are given the interval of 1 to 4. So if you are given the interval of 1 to 4, x2 is equal to 4 and x1 is equal to 1. So we are going to, first of all, we need to find our f of x2, which is f of 4, which is going to be 4 raised to the power of 3 minus 8 into 4 minus 5, which is equal to 64 minus 32 minus 5, which is equal to 27. Then we go on to find f of 1, which is 1 raised to the power of 3 minus 8 into 1 minus 5, which is equal to 1 minus 8 minus 5, which is equal to minus 12. Then we'll go ahead to find our f prime of x, which is the differentiation of f of x, and f of x is equal to s cubed minus 8x minus 5. So if you differentiate s cubed, you are going to have 3x squared. If you differentiate 8x, you are going to have 8, and if you differentiate 5, you have 0. So you have f of x naught is going to give you 3x naught squared minus 8. And according to the formula that we have here, the formula says that f prime f of x2 minus f of x1. So f of x2 is 27, then minus f of x1, that is minus 12, which is this one and this one, then is equal to f prime of x, that is our equation, that is 3x naught squared minus 8 into x2 minus x1, that is 4 minus 1. So we'll continue by saying that 27 plus 12 is equal to 3 into 3x naught squared minus 8. The reason why we have this 3 here is because 4 minus 1 is equal to 3. Then if you add it, you are going to have 39 equals 3 into 3x naught squared minus 8. You can go ahead to open the bracket. You have 39 is equals to 9x naught squared minus 24. Therefore 24 plus 39 is equals to 9x naught squared, which is equal to 63. 63 is equals to 9x naught squared. Dividing both sides by 9, 63 divided by 9, so you are going to have 7. You take the square root of both sides, then you have square root of what? Of 7. So therefore you can say that 1 less than root 7 less than 4. So we discover that it satisfies the mean value theorem. So let's go on to another example. If you are given a curve also, f of is equal to x cubed plus 1 with the interval of minus 2 to 4. So the first thing we do is that we look for our f of 4. F of 4 will be 4 raised to the power of 3 plus 1, which is going to be 64 plus 1, which is 65. Then f of minus 2, which is going to be minus 2 raised to the power of 3 plus 1, which is minus 8 plus 1, which is equal to minus 7. Then you're going to find your f prime of x. F prime of x is going to be differentiation of f of x, and f of x is x cubed minus plus 1 rather, so it's going to be 3x squared then plus 0, or which is what, 3x squared. then your f prime of x naught is going to be 3x square naught. Then you can say that you using that formula, you discover that f of 4 minus f of minus 2, which is going to be 65, minus into minus 7, which is equal to, that's 3x naught square, then into 4 minus minus 2. So we are going to have 65 plus 7, because 1 minus times minus will give you plus, then which is going to be 3x square naught into, this is going to be 4 plus 2, then you have 72 is equal to 6 into 3x naught square. Therefore we are going to have 18 x naught square is equal to 72. Then x naught square is equal to 72 divided by 18, and x naught square will be equal to 4. X naught is equal to 2 when you take the square root on both sides, and you discover that putting it in between the interval, you discover that minus 2 is less than the x naught, which is 2, less than 4. Therefore satisfy the mean value theorem. So that is that for today's video. Make sure you like the video, you comment, you share, and don't forget to subscribe. See you in the next video.